The sun is the source of most of our energy here on Earth. Energy from the sun is used to produce electricity using photovoltaics and solar thermal plants. That same energy is also used for heating using solar domestic hot water systems, hydronic heating, solar air heating, and solar cooking, just to name a few. This video will talk about how the sun produces that energy. The sun produces energy using a process called fusion. Let's start our explanation of fusion with the atom.
The shorter the wavelength, the more energy carried by the wave. The wavelength of emitted radiation is determined by the temperature of the object it comes from. The higher the temperature, the shorter the wavelength of emitted radiation. The sun, with its high surface temperature, emits a great deal of high-energy, short wavelength radiation.
Collecting 40% more energy than passive heaters. The hot water is then efficiently stored, mixed, and distributed, delivering child-safe water to the bathrooms and piping hot water to the rest of the house, even on cloudy days.
Carl Peterson, Energy Educator with North Dakota State University, and today what we're going to be talking about is the effectiveness of insulation. In our northern climates, the majority of our energy use in the house is through heating. So we're going to mainly focus on heating, but also in the summer months we're thinking about cooling too, but we'll focus on the heating aspects of it. But the idea is that, the house is like a balloon here, and to fill up this balloon, to keep the air inside of this balloon, we have to make sure it's nice and air sealed. The same thing was with a house. If we want to keep that heat in that house as long as possible, we have to make sure it's nice and sealed up tight. The other thing is that eventually this air is going to leak out of this balloon. Same thing with a house. That heat can transfer through and out of a house in a number of ways. It can go right through building components. It can sneak through around gaps in those building components. It can also have convective currents in there where that air gets heated and cooled and the air moves inside the building components or right up against them, like around a cold window or something like that.
Effect known as the greenhouse effect. This phenomena is known as the greenhouse effect because, like the glass in a greenhouse, the atmosphere traps some of the energy beneath it. The greenhouse effect produces a warmer climate on Earth than would be possible without an atmosphere. In summary, water
Sun? Yes, indeed. First, let's talk about the heat, since that's really what this case is all about. Now, believe it or not, heat is a form of light.
What?
Here, Mr. Savage, take this flashlight and shine it at this mirror.
I can't see.
And why not?
Because the light is reflecting back into my eyes.
That's right. Now, the important word here is reflecting. Because now, Mr. Savage, I want you to shine the light at this old piece of wood. Okay, good. Now what's happening?
I'm still having trouble seeing.
Very good, Mr. Savage. So where does the light go?
Some of it gets absorbed in the wood.
Absorbed into the wood?
That's right. The light gets absorbed right into the wood.
You mean like a sponge?
Well, yeah, I guess. Well, heat can be either reflected or absorbed, just like light.
I don't get it.
I'd better show a demo. Fred, could you turn on the laboratory sun lamp, please?
Okay.
Hey, the temperature's going up.
Now, do you know why?
Because the sun lamp is very hot.
Well, that's right. But look, the thermometer with the black shirt is heating up faster.
So that explains why Mr. Richmond was very hot and felt faint.
That's right.
Just because of the shirt color?
That's correct. The black absorbed a lot of the heat while the white reflected it. Do you know why a white shirt like this looks white to us?
Because it's white?
No.
How could I have missed that one?
It looks white because it is made in such a way as to reflect light and heat. The white color you see is actually reflected light and heat coming off the cloth.
But the black cloth of this shirt is not reflecting any light or heat, is it?
No, ma'am, it isn't. It's sucking the heat and light in and trapping it, getting hotter and hotter.
Thank you, Professor Parsons.